Welcome to Study Loop.
So on the screen, I have drawn terephthalic acid and ethylene glycol in order. And what we want to show is the structure of the dimer formed between these two species that then goes on to form a type of polyester. So as you're looking at these two structures, you can hopefully see the commonality between them that ultimately helps them form this polyester linkage. So if we remember that there's two electrons on these hydroxides on both of these species, if we think about these electrons forcing their way onto this carbonyl ester and forcing the displacement of this OH group, it becomes easy to see that the linkage between these atoms is actually through that OH linkage. So the way that this winds up looking after we come back and deprotonate the extra hydrogen that will be left on. So if you're curious about how this works from an organic standpoint, this hydroxide gets kicked off as a negative hydroxide, and this bond will cause this oxygen to have a partial positive charge, and this hydroxide winds up coming in and taking this hydrogen back off there to get us to this final product. And this is essentially going to be the dimer that we will then use to polymerize and form this polyester using, in the next step, this hydroxide and displacing the left hydroxide from the next dimer in the chain.